In this video, we are still factorizing, and we are going to be doing 3 examples of factorizing using cubes. And we're going to use our special formula that I also just copied for us over here that you need to know. Let's just talk about what are cubes. For example, if I've got 1 cubed, it's just 1. If I've got 2 cubed, that's 8. If I've got 3 to the power of 3, that gives me 27. So these are all cubes. I can get the cube root of all those numbers. And it's nice when you know them, because then you can easily recognize when you see, I can factorize using cubes. All right, let's look at the first one. So for the first one, we've got y to the power of 3, which makes it a cube. And we just looked at 8. 8 is a cube. Using our special formula, it will break up into a binomial and a trinomial. Those will be our 2 factors. What goes into our binomial? Well, it will be the cube root of y to the power of 3, which is just y, and then the cube root of 8, which is 2. So we're going to use that. So my first factor will be y. Sign stays the same as the question, y minus 2. And then we can use this first bracket and then we can use this first bracket to determine what goes into the second bracket, which is a trinomial. So if we square the first term, that gives me y squared. If I square the second term, that gives me 4, and it will always be a positive. And then for the middle term, we get the product of these 2 terms, product meaning multiply. So that will give us 2y, and the sign will always be the opposite of what it is in the sum. And there we did it. We factorized using cubes. How can we check if this works? Well, if we multiply it back out, we will get back where we started. Shall we just quickly do that? So if I multiply that, it would give me, see, I did a very silly thing there. You saw that, hey? That should be a square. I think I said square, but maybe wrote a cube. So if we multiply that out, it's going to give us y to the power of 3 plus 2y squared plus 4y. So we're also practicing our simplifying skills. Minus 2y squared minus 4y, and then take away 8. If we look at that, do you see that those 2 will cancel out? These 2 will cancel out, and we are left with y to the power of 3, and we are left with 8, back to where we started. Let's look at the second one. We first need to look and see if those are cubes before we can use this method to factorize. I immediately see that, and that will be a cube, and we'll talk about that some more just now, and that is a cube. But if I look at 16, that's not a cube. I can't get the cube root of that. And 54, no. So at this stage, we can't factorize using cubes. However, there is a highest common factor that we can take out. Think about 16 and 54. There's definitely a common factor that we can take out, 2. And that would leave us with 8x to the power of 6 plus 27y to the power of 3. And now note, this is a cube. So is this. So now with this bracket, we can factorize using cubes. Let's do that. That will break up into a binomial and a trinomial. And what will go in there? Just what I want to remind you of. So if you have x to the power of 6, and we need to check and see if that is a perfect cube, well, in other words, that is what we need to work out. If we think about this, we've got x to the power of something times x to the power of the same thing, and x to the power of the same thing must get me back to x to the power of 6. Our exponent laws are so important in this. It must be 2, because 2 plus 2 plus 2 gives me 6. So it means that the cube root of x to the power of 6 is x that is being squared. What's the shortcut? Well, if I give you x to the power of, say, 21, and I need to get the cube root of that, I need to check and see if it is a cube. Then the answer would be x to the power of 7. How do I know that? Well, x to the power of 7 times x to the power of 7 times x to the power of 7 will give me x. That's not an x. X to the power of 21. So it works. But there is a shortcut that we can use. If you take this one, 21, and you divide it by 3, it also gives you the 7. If you take the 6 there and you divide it by 3, it gives you the 2. That's not going to work. The 2 there. Right, so remember that. So we've got perfect cubes there. Let's put them in the brackets. Cube root of 8, so I've got 2, and then x, that is being squared. And then plus, the sign must stay the same as in the question. And then the cube root of 27 is 3, and then just y. So there's our first bracket. Let's find our second bracket. I'm going to square this one, which is going to give me 4x to the power of 4. Then I'm going to square that one, which is going to give me 9y squared, and the sign will always be plus. Then I'm going to get the product of these two terms. So I'm going to multiply them by one another, which is going to give me 6x squared y, and the sign will always be the opposite. So in this case, it would be that. And there we factorized using cubes. To check if we're correct, we can obviously multiply those out and make sure that we get back to 8x to the power of 6 plus 27y that is being cubed. One more. First, we need to check if these are cubes, because remember, your question will most probably just say factorize, and you need to decide, is it a highest common factor, or dots, or trinomial, or grouping, or whatever. So we need to check that these are cubes. We know that 1 is a cube, and we know that y to the power of 12 is, because 12 is divisible by 3. 12 is divisible by 3. 12 divided by 3 will give us y to the power of 4. So we do have a cube and a cube, so we can factorize it. There is our binomial. There is our trinomial. So if I put this into my bracket, that would be y to the power of 4. Sign is the same, minus 1. And then for the second bracket, I'm going to square that one, which will give me y to the power of 8. Let me just use that one. Y to the power of 8. Then I'm going to square this one. 1 squared is just 1, and the sign will always be plus. Then I'm going to get the product between these two. I'm going to multiply them with one another, which will just give me y to the power of 4, and the sign will always be the opposite of what it is in the first bracket. And there we factorized it. What's going on with that first bracket? Is that fully factorized? Isn't there something else we can do there? Surely we can use dots, the difference of two squares, because I've got a perfect square. I've got a perfect square where that one is y squared, and the square root of 1 is just 1. So I've got two perfect squares. How do we do that again? That bracket will break up into two sets of brackets. Y squared, 1, 1, 1 plus, and 1 minus. And then obviously, don't forget that bracket. That one needs to tag along. There we go. Now let's just quickly evaluate and see, make sure that we're done. Well, if I look at this, we've got dots again. Do you see that? So that bracket over there, I'm just tagging this one along. The order doesn't matter there. This bracket over here is dots again. So it's going to break up into two sets of brackets. The square root of y there, y squared, is just y and y. The square root of 1 is still 1 and 1, and then 1 plus and 1 minus, and don't forget that last bracket. And let's evaluate and see if it is now fully factorized. Yes, finally. So there are our factors. It's fully factorized.